Beneath the waters off Florida's coast, the U.S. Navy has achieved something that had eluded them for over 4 decades. After countless failed attempts and billions of dollars spent, they've finally created a vessel capable of fundamentally transforming how their elite special operations forces conduct underwater missions. For years, the conditions faced by Navy SEALs on board their delivery vehicles had been brutal, as they were forced to spend hours in freezing cold water. The very technology meant to deliver them to their targets often left them physically and mentally drained before their missions even began. With not only the personal well-being of their commandos, but the very success of their high-stakes operations hanging delicately in the balance, the Navy urgently needed to find a solution. Finally, an answer has emerged. Berthed at Lockheed Martin's Palm Beach facility, this streamlined 39-foot vessel is unlike anything the Navy had previously deployed, and its cutting-edge systems promise to radically enhance the way in which their most formidable warriors carry out their vitally important interventions. Background. For decades, Navy SEALs faced extremely challenging conditions during underwater missions. Inside their SEAL delivery vehicles, or SDVs, members of this elite force had to endure seemingly endless hours fully submerged in frigid water as they transited to their objectives. In the Navy's Mark 11 SDV, operators would spend up to 9 hours exposed to the elements while traveling distances of 36 nautical miles. Wearing wetsuits and scuba gear the entire time, they couldn't even hydrate during these lengthy transits. Even in warmer regions of the world, the considerable depths at which submersibles would often have to travel to avoid detection meant that water temperatures could still be dangerously low. The impact on combat effectiveness was profound. When SEALs finally reached their targets, whether it was a hostile shoreline, an enemy vessel, or underwater infrastructure, they were often already battling fatigue and the early stages of hypothermia. For missions requiring precise movement, steady hands, and sharp decision-making, this cold-induced deterioration could mean the difference between success and failure. In 1998, Lieutenant Commander Christopher J. Kelly conducted a study that highlighted the issue, concluding, quote, "Water temperature can be a more limiting factor than battery capacity." The Navy had actually been trying to solve this problem since the 1980s, but their attempts proved to be woefully inadequate. Their first major effort, the Advanced SEAL Delivery System, was plagued by technical issues. The prototype proved noisy, underpowered, and after years of delays and cost overruns, was destroyed in a fire in 2008. A follow-up joint multi-mission submersible program was axed just 2 years later. The Navy's wet submersibles, while stealthy and effective for shorter missions, simply couldn't protect their occupants from the punishing effects of prolonged water exposure. As global tensions rose and underwater operations became increasingly crucial to national security, the need for a revolutionary approach became clear. Development. In 2016, the U.S. Special Operations Command launched an initiative for a new vessel capable of providing a significant leap forward in Navy SEAL transportation. The $166 million contract went to Lockheed Martin, who partnered with British submarine manufacturer M-Subs to combine American defense expertise with European submarine design innovation. The team based their proposal on M-Subs' existing S-351 Nemesis platform, which evolved from earlier successful designs such as the S-302 and S-301I submersibles. While those earlier vessels were small enough to fit in submarine dry deck shelters, the S-351 represented a larger, more capable platform, exactly what the Navy needed for its new underwater vehicle. The team focused on adapting and enhancing this proven design to meet the rigorous demands of SEAL operations. The initial order called for 3 prototype vessels, but the project would soon prove more ambitious and more expensive than initially planned. As development costs rose to $236 million by 2018, skeptics questioned whether this attempt would fare any better than its predecessors. Unlike previous programs, this one steadily progressed from design to reality. By early 2023, after years of careful development and rigorous testing, the first 2 vessels were ready for operational trials. In March of that year, one of these prototypes departed Lockheed's Palm Beach facility for open water testing. 2 months later, Program Manager John Conway received the news they'd been waiting for. The operational test report showed the vessel had exceeded expectations. By June, the dry combat submersible had achieved something its predecessors never could: initial operational capability. Design. At first glance, the dry combat submersible appears deceptively simple. A sleek 39-foot vessel with a beam of just under 8 feet, weighing just under 15.5 tons when fully loaded. Yet beneath its aluminum and fiberglass hull lies an intricate system engineered to revolutionize underwater operations. The DCS divides its pressurized interior into 3 distinct sections. In the aft command center, a 2-person crew pilots the submersible through waters up to 330 feet deep. The main compartment accommodates 8 fully equipped SEALs, quadrupling the passenger capacity of its predecessor. But it's the central section that houses the vessel's most innovative feature: a sophisticated lock-in, lock-out chamber capable of operating at depths of up to nearly 100 feet that allows operators to exit and enter while remaining completely submerged, maintaining stealth throughout their mission, even in challenging conditions. Lockheed Martin's C6ISR Vice President Greg Bauer explains, quote, "The DCS provides safe, clandestine delivery for occupants over long distances in a completely dry environment. Occupants arrive at their objective warm, rested, hydrated, and ready, making this vessel a key advantage in mission success." Yet the submersible's capabilities extend beyond operator comfort. Its all-electric propulsion system maintains near-silent operation while cruising at 5 knots. With an operational range of 60 nautical miles and endurance exceeding 24 hours, triple that of previous vehicles, it offers unprecedented flexibility for mission planners. What's more, its integrated suite includes an inertial navigation system and Doppler velocity log for precise underwater positioning, while sonar and fathometer systems provide detailed awareness of the surrounding environment. For mission coordination, the vessel is equipped with both an underwater telephone and UHF radio communications. What's more, a comprehensive support system has been established, including lifecycle maintenance, post-delivery logistics, and specialized training programs for both pilots and special operators. This infrastructure ensures the safe and effective operation of these sophisticated vessels in future Special Forces efforts. Operations. The DCS dramatically expands the scope of what Special Operations Forces can achieve underwater. Navy SEALs can now infiltrate enemy ports undetected, conduct underwater sabotage operations, or slip behind enemy lines while maintaining peak physical and mental condition. The vessel also supports underwater demolition missions and provides new options for gathering intelligence in denied areas. For Special Operations planners, this versatility opens up possibilities that were previously impractical due to the physical toll of cold water transit. Highlighting how long forces had waited for this kind of mission flexibility, Navy Captain Randy Staff says that the introduction of the DCS, quote, ends a capability gap of 15 years, more than 15 years. Challenges. However, for all its many advantages, the DCS also comes with a major challenge. Unlike the wet submersibles it replaces, it cannot deploy from the Navy's current fleet of submarines. Its size makes it too large to fit inside existing dry deck shelters, specialized modules that allow submarines to launch smaller vessels while submerged. This constraint has required alternative deployment methods. For now, surface ships, such as amphibious warfare vessels, serve as the primary launch platforms. The military has also begun exploring additional options. In at least one test, a DCS prototype was successfully transported inside a shipping container aboard a C-17 Globemaster III cargo aircraft, suggesting one possible pathway to rapid deployment. The need for solutions becomes more pressing as the Navy prepares to retire its 4 Ohio-class guided missile submarines, vessels specifically designed to support special operations before the end of this decade. While a new dedicated replacement for these platforms remains decades away, development has already begun on an improved DCS Next variant, with one key goal being deployment capability from Virginia-class attack submarines. Conclusion. Even as the Navy looks to future variants, the significance of today's DCS should not be underestimated. After decades of attempting to solve the punishing realities of underwater transit, the U.S. military has finally fielded a vessel that could fundamentally reshape how Navy SEALs and their international counterparts operate beneath the waves, with Greg Bauer noting, quote, "The dry combat submersible has the potential to transform undersea warfare for special operations." As naval warfare continues to evolve and underwater operations grow more complex, this breakthrough in subsurface transport may prove to be a turning point in how nations project power at sea.